next at sort of the 2B section of the book, and it starts off with mapping. So what you need to take from this is really the key terms, domain and range. Okay, domain and range, this refers to inputs, yeah, your x values, in other words, most of the time. Okay, and range, your output, what come out of the functions, what are the y values. Think of domain and range like looking at your results in science and thinking about how much space you need when you're going to draw a graph. Domain would be the x values, okay, range would be the y values, the outputs. And we can change letters, of course, and use equations with t and s and whatever, but domain are the numbers that you start with. Okay, what are the full set of numbers that you can start with? Range, what are the full set of numbers that can come out from that equation or function? So what is a function exactly? Well, a function is going to be some kind of mapping arrangement so that every element of the domain, in other words, every single x value that's part of the inputs, is mapped to exactly one element of the range. So that means each x value has an output and it has one specific output. We're going to have a look at that with these sort of different functions here. So the first one, don't worry about what it is, okay, just think about the shape and the inputs and the outputs. And for all of these here, because I can't make this clear in the graphing software, I'm going to say that my domain looks like this. And what this means is my domain, okay, I'm saying you can pick x as long as x belongs to real numbers. It's not a complex number. You don't need to worry what that is. But it means I can pick positives, negatives, fractions, rational, irrational, pi, something like that. Okay? So if I pick any value of x, does it have one specific y value? So if I pick 4, 4 returns 1. It doesn't return any other numbers. If I look above and below, there are no other numbers. So yes, this is a function. Let's pick 2 to the power of x. So if I pick a value like minus 5.6, does it have one specific y output? Yes, it does. It's a very low number. Of course it is. Okay, because it's an exponential graph. But it does have one specific output when I say that the domain belongs to all real numbers. Let's do another one. So this is the principal root of x. And you'll realize it's only returning positive values. Okay? And again, I'm going to use the same condition for domain. I'm going to say this should work. So each x value should return a y value for all the real numbers. 6 seems to have one y value, for example. But this is not a function. Why is it not a function? But what happens if you try picking minus 1? Where is its one specific output? It doesn't exist. So this is not a function. Let's look at the case. So I want you to consider the red and blue lines together now. Let's consider the case of plus or minus, okay, plus or minus root x. So is this a function? Is this a function if I restrict the domain, if I say you can only do this where x is greater than or equal to 0? That kind of fixes the problem before. So is it a function now? Well, if I pick a number like 4, it seems to have 2 y values, so it does not have one specific output. So in summary, what we can say then for the ideas on here: yes, we have a function. Yes, we have a function. No, we do not have a function. And this one above, the last one here, no, it's not a function. Okay, and we're going to move on in the next video to looking at range for certain functions with restricted domains, and we're also going to have a quick look at something called piecewise functions.